the Chapter 11 review, and we are starting with just things you needed to know. And so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and then 14 squared is 196, and then 15 squared is 225. Your distance formula is the difference in the x's squared, and you can put the subscripts down here, and if you have the 2 here and the 1 here, that's fine, and the difference in the y's squared, all under the square root. And then the midpoint formula, we add the x's and divide by 2, add the y's and divide by 2. Moving on, labeling the special triangles, this would be S, S, and S square root of 2. On the 30, 60, 90, across from the 30 is the S, the hypotenuse is 2S, and this is S square root of 3. Again, across from the 30 is the S, the hypotenuse is 2S, and across from the 60 is S square root of 3. This is a leg, and a hypotenuse. Legs are touching the right angle and they are shorter. And then the Pythagorean theorem, a squared plus b squared equals c squared, which is leg squared plus leg squared equals hypotenuse squared. You have to pay attention when you're doing this. They may give you the hypotenuse. Don't just assume you take the two numbers that are there and square them and add them up. It may be that you have a leg and a hypotenuse and you're looking for a leg. Complete the ratios. Sine is opposite over hypotenuse. Cosine is adjacent, and those are legs. Opposite and adjacent are legs. Over hypotenuse. Tangent is opposite over adjacent. And remember, we had Chief SOHCAHTOA. That helped us remember the order of things. Draw an angle of elevation or inclination. They always go from a horizontal upward. So it could look like that, or it could look like that. An angle of depression is always from a horizontal downward. So there's my horizontal and there's my downward. And then at this point, we start in on the actual chapter review, which is on page 621 to 623. The square root of 1 is 1. This would be -4. This is 7. This is 8. -6, because we take the square root and then make it negative. 121. Oops. 11. Because 11 squared is 121. 196, that would be -14, and this would be 9. Remember again that the square root is asking you what number times itself, in the case of number 8, what number times itself equals 16? Well, the answer is 4, and then we made it negative. Number 9, what number times itself equals 49? The answer is 7, not 7 squared. Just 7, because the square root is asking you what number times itself equals this. Here, this is between the square root of 4 and the square root of 9, and it's closer to the square root of 4, so it's 2. This is between the square root of 9 and the square root of 16, and it's closer to the square root of 9, which would be 3. This is closest to the square root of 36, which would be 6. This is closest to the square root of 64, which would be 8. 91 is between the square root of 81 and 100, and it's actually closer to the 100 than it is to the 81, so that's 10. Telling whether it's rational or irrational. A rational number is a fraction a decimal that repeats exactly or ends, so terminates, it stops, and then a perfect square square root. So like the square root of 16 would be rational. Irrationals are decimals that don't end or repeat, and radicals that are not a perfect square. So this one ends, the 0.55 ends, so it's rational. Square root of 64 is just 8, so it's rational. 0.45, and notice that little marking there, that indicates that this repeats. And so since it repeats, it's rational. Square root of 50 is not a perfect square. So that's irrational. And then here we have 0.123, 0.123, 0.123. So it doesn't end because of those ellipses, but it is repeating. The 123 is repeating. So this one is rational. And then in number 22 says, explain why this is irrational. And the reason why it's irrational is it does not repeat or end. The ellipses tells you it keeps going, but it's 1 2 and then 1 2 2 and then 1 2 2 2. It's not repeating. The pattern is it's adding a 2 each time, but it's not a repeat. And then here, can a right triangle be formed? I have a typo there. I'll fix that on yours. With the 3 lengths given, show your work and use the table on 778. So a right triangle would be the 2 smallest sides squared equaling the largest side. Does that equal? And that's a question mark right there. So 1 squared is 1, 3 squared is 9, 3 squared is 9, 10 does not equal 9, so no. Here, square root of 6 squared plus square root of 10 squared equals 4 squared. I don't know what the square root of 6 is, but if I square it, I'm going to get 6. I don't know what the square root of 10 is, but if I square it, I'm going to get 10. 4 squared is 16. 16 does equal 16, so yes, we can get a triangle there. 30 squared plus 40 squared equals 50 squared. So we're checking that. 30 squared would be 900. 40 squared would be 1600. 50 squared would be 2500. And if you add 900 and 1600, you get 2500. So yes. So on this, you did have to show your work. You had to prove yes or no. And the 30 squared, how I got that, 2 placeholder zeros, 3 times 3 is 9. I didn't use the table. 40 squared, 2 placeholder zeros, 4 times 4 is 16. 50 squared, the same thing. 2 placeholder zeros and 5 times 5 is 25. So that's the longhand on that. Find the distance. So your distance formula is D equals x minus x quantity squared plus y minus y quantity squared. What I'm going to do when I give your test is you will have a page very similar to this first page that you have to fill out, and then you'll turn that in, and then I will give you this information for the rest of the test. So I will probably have you go down to about right here, maybe, where you can't use the table or anything, and then from there, so you will, once you get to here, you'll have the distance formula. You will have to write it initially on the test and prove that you know it, but once you get to here, I will supply it so that you can use it in the problem. So the distance equals -1 minus 3 quantity squared plus 7 minus 10. And you could have flip-flopped the order of the subtraction on these, and it's not going to affect your answer. Changing signs, I'll do that in orange so that you can see that. Changing signs and adding -1 and -3 is -4. 7 and a -10 is -3. So we're going to have 16 because -4 times -4 is still positive. 3 times -3 times -3 is +3. So I end up with the square root of 25, which is 5. And on this one, x minus x quantity squared plus y minus y quantity squared. 4 minus a -8 quantity squared plus -5 minus a -1 quantity squared. Again, doing the sign change in a different color so that you can see that. When I do my sign change, I always make 2 marks, and those 2 marks have to be between the 2 numbers. You don't just change like the negative in front of that 5 up there. So 4 plus 8 is 12. -5 +1 is -4. 12 squared is 144. -4 times -4, which is -4 squared, is 16. So 144 plus 16, 10, carry the 1, is 160. And then if you look on page 778, you would have that one, to the nearest tenth. You're not going to be able to do that using the table. Okay, you would have to use, you could find it to the nearest whole number by looking in the n squared column and find out that it's 13. Um, so when you do these, I will make sure that you have ones that you can use the table for. So they would have to be less than 100. But if you don't have that, you have to use a calculator. So the square root of 160 is 12.6. So I'll put a note on there to use your calculator to find the square root once you get down there, because you won't be able to use the table to do it. On this one, we're finding the midpoint, and to find the midpoint, we add the x's and divide by 2, and we add the y's and divide by 2. So we have 2 plus 4 over 2 and 6 plus 2 over 2. So we have 6 over 2 and 8 over 2. 6 over 2 reduces to 3, 8 over 2 reduces to 4. And again, our formula again. So we have -7 plus 3 over 2 and 8 plus a -4 over 2. Both of these ended up as whole numbers. -7, +3, the signs are different. Find the difference and keep the sign of the larger. Same thing happens here. Find the difference, keep the sign of the larger. So -4 divided by 2 is -2. 4 divided by 2 is 2. If you end up with something that is like an odd number, like 7 over 2, just leave it as an improper fraction. That's fine. Moving on. These are similar triangles. Sorry about that. And there's a word problem that goes with this, which was on page 622, but we're looking for this side right here. So we have A going with 168 is equaling to 448. Notice A and 448 both come from the same triangle, going with 223. And on this one, I said don't solve it, just because the calculations were taking so long. On this one, my proportion would be The 4.8 is going with the x, because those two, and then the 7.2 is going with the 24. And so we're going to cross multiply. We would get 7.2x, and then 24 times 4.8. 32, carry the 3. 16 plus 3 is 19. 4 times 4 is 16, carry the 1. 8 plus 1 is 9. 15, carry the 1. And so I get 115.2, and I need to divide both sides by 7.2. And let's see. I'm going to move my decimal. 6. 6 times 2 is 12. Carry the 1. 42 plus 1 is 43. So it goes in 16 times. And so x equals 16 feet. And so that's how you do similar triangles. You set up a proportion and then cross multiply. In 40, 41, 42, and 43, you have special right triangles and you have to find the missing sides. So let's go through and put in our side ratios or our side lengths. Across from the 30 is S. Across from the hypotenuse is 2S, so that equals 12. And this is S square root of 3. So if 2S equals 12, then dividing both sides by 2, S is 6. Which means this side is 6 and this side is 6 square root of 3. On 41, S, and S square root of 2 for my right triangle, 45, 45, 90 triangle. So that's S is 7. So this would be 7 square root of 2, and this would be 7. Down here, across from the 30 is S. The hypotenuse is 2S, and this is S square root of 3. So S is 2, so that means this is 4, because 2 times 2 would be 4, and this would be 2 square root of 3. So all I do is replace the S with whatever I've found S to be. Here, this is S square root of 2, this is S, and this is S. So obviously the S is 10.6. So that's 10.6. That's all you have to do. You didn't have to find this side, but it would be the same measurement. And then here, you're using the table on page 779 or a calculator. The one advantage I would say to the table is that you don't have to think about the rounding because it is already rounded for you. You do have to make sure you're in the right column though. So the sine of 16 is 0.2756. So here it is on the calculator. And that was the sine of 15 on your calculators. Oh, it was 16. On your calculators, you have to hit the sine button first. On this calculator, I have to hit it second. So then the tangent of 82 is 7.1154. You can see on the calculator there that you would have to round, pull it back up, you would have to round that 3 up to a 4. And then the cosine of 25 is 0.9063. And then the tangent of 3 is 0.0524. Show that on the calculator. There it is. The sine of 87 is 0.9986. There it is. And then the cosine of 73 is 0.2924. That was me reading it off of the table. And you can see here, this is another one that you would have had to have rounded. And then number 54 in the chapter review. Get there? That's me flipping pages if you hear something. It says a loading ramp forms a 28-degree angle with the ground. So here's the ground, and that's 28 degrees. If the base of the ramp is 15 feet long, how high does the ramp reach? Okay, I don't like the verbiage here. I would have said the base of the ramp is 15 feet. Because in my mind, a ramp is just like a ladder leaning up against something, but I think what they're saying is the whole thing is solid. So this is our picture. So we have an angle, opposite, and adjacent. So this is the tangent of 28 degrees is equal to x over 15. And so the tangent of 28 is 0.531. And then we could multiply, we could cross multiply, so we have 15 times 0.5317 equals x. And I told you on these you could use a calculator just because, again, we've got such arduous calculations. So it says round to the nearest unit, so do 8 feet. And then number 55, it says Melanie is flying a kite and lets out 100 feet of string. So here's our kite. We have 100 feet of string. Rosa determines that from Melanie's hand, the angle of elevation to the kite is 71 degrees. Melanie's hand is 4.3 feet from the ground. So this one took a little more thought because of that piece of information. What is the height of the kite? So I'm going to start with this. And I've got the angle, opposite, and the hypotenuse. So that is the sine. So the sine of 71 degrees is equal to opposite over hypotenuse. So the sine of 71 is 0.9455. You can cross multiply and you would get 94.55 equals x. 100 times 90.9455. But that is that distance from here to here. But we have to add to it that 4.3. And so we have 98.85 feet is how high the kite is off the ground. And my instructions said to round to the nearest unit, so it would be 99 feet. On this one, remember sine is opposite over hypotenuse. So here's A. Opposite of A would be 12. The hypotenuse is 20. Both of those are divisible by 4, so we get 3/5. The cosine of A is adjacent over hypotenuse, 16 over 20. Both of those divisible by 4, we get 4/5. Odd numbering pattern here. Going across the cosine of B, so I've switched angles. So that's adjacent over hypotenuse, which would be 12 over 20, which will reduce to 3/5. And then the tangent of A, opposite over adjacent, 12 over 16, both divisible by 4, we get 3/4. The sine of B, we switched angles, so opposite over hypotenuse, 16 over 20, which would be 4/5. So we're getting same answers there. Well, you've only got 3 legs to the triangle. So yeah, you're going to have some repeats of your numbers if you switch angles. And then the tangent of B would be opposite over adjacent, which would be 16 over 12, which would reduce to 4/3. You can leave that as an improper fraction. And then the last two, find the missing side. So a squared or leg squared plus leg squared equals hypotenuse squared. So 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144. They add up to 169. So c is the square root of 169, which this is actually a perfect square. It's 13. On this one, a squared plus b squared equals c squared. So we have 12 squared plus b squared is unknown. C is 24. And so we can use our table on page 778. And so 24 squared, 12 squared is 144. That one I know. 24 squared is 576. So subtract 144 from both sides. And that's 2, that's 3, that's 4. So I want the square root of 432. And I can get to the nearest tenth or to the nearest whole number, which would be about 21 without using a calculator, but I would have to use a calculator to get the square root without that. And it was 20.8. So on your test, if I'm only allowing you to use your table, I will have to make sure your square root is, you're taking a square root of a number less than 100, or tell you to round to the nearest whole number. So that's your review for chapter 11. Generally speaking, the only place you're going to use your calculator will be when you are doing ones like this, starting here through here will be when you'll have access to a calculator.